Excellent. So hi, everyone. My name is Roya Amjadi. I work with Federal Highway Administration, Internal Highway Research Center. I manage the crash modification factor programs and the evaluation of the low-cost pool fund safety study program. I'm going to talk to you about the guardrail and utility pool and the flattening site slope study that we did for this pool fund study. Briefly, for those of you who don't know what the pool fund study is a study, research study sponsored by Federal Highway Administration, and it has been 16 years operating. It has 41 state members that they are supporting this research effort. You see all the blue state involving in this study here. Then let me tell you about the study summary. I'm going to go fast because I got 8 minutes. Please contact me for more information. The reason we did this study is that hardly there is much research on the roadside safety issue. You know that 50% of the fatal crashes are roadway departure and 40% of them are fixed object, and 3% of those is involving tree or post. In our study, we considered the guardrail that they were installed in front of the poles to protect them, also removal and relocation of the utility pole, and then also we looked at the flattening the site slope as a safety countermeasure, collected data from the state of Indiana and Pennsylvania, and we concentrated on the total and injury crashes and the roadway departure crashes. Here are some of the summaries for you. For the protecting the pole with the guardrail, we found out that total and the roadway departure crashes, they have 0.9 and then up to 1.52 CMFs, but the crashes reduces only depending on the location of the pool with respect to the edge of the roadway. The closer the poles are, possibly we get less safety improvement. For the total and injury crashes, the CMFs were 0.52 and 0.43, and they were statistically significant. But again, that all depends on the location of the pole with the roadside. For the pole removal and relocation, we got 0.65 or 0.66 for the pole removal and 0.87 for the pole relocation. So we see that removal could be a bit more effective. For the slope side improvement, total crashes came up with a CM of 0.92 and 0.93, depending on the slope of the road that we begin with. Then for the roadway departure crashes, their CMFs were 0.78 and 0.95, depending again on the initial side slope. The cost-benefit factors for the guardrails were 1.28 to 1.48. For the pole removal and relocation, were a bit higher, 6.73. That doesn't include the cost of the purchase of the right-of-way. Here are some of the data we used. We used the SHARP2 road information database. We manually collected data from the Google image. Also, our data came from Indiana and Pennsylvania. This is how we collected the information or the data from the Google image. The TTI, which is the contractor, they developed technology to measure like the shoulder, the lane width, the side slope, and the distance to the nearest fixed object. That was very effective. These are the data that we collected from Indiana. Average daily traffic, total crashes, fatal injury, roadway departure, fatal injuries. And again, these are the data we collected from the Pennsylvania, most the same variable. But our most important tools were the statistical methodologies that we used. We used cross-sectional study to combine the two states' data. For the data collection, we used the propensity score methodology. And then for the data analysis, we used the propensity score weighted methodology. For developing the models, we used the mixed effect generalized linear model. That was the secret to our success. Here again are some examples. There is much more than this. So for example, if you install a guardrail in front of the pole, which is less than 24 feet away from the road edge, we found out that the fatal and injury crashes, they improved by 48%, and this reduction is statistically significant. Another example is if you evaluate the guardrail that protects a pole with 20 foot and more distance from the edge of the road, then you get a higher statistical significance of 58% reduction. And again, we have considered the ratio of the vertical to the horizontal slope here, so that they were variable in the term of evaluating our CMFs. For the pole removal, removal and relocation, we got significant reduction in fatal and injury crashes by 45%. And again, that depends on the location of the pole to the road. For the flattening roadside, we had different ratios for the slope. Here, the slopes were reduced from the ratio of 1:4 or 1:5 to the horizontal of 1 to horizontal 6 or flatter. Total and the departure crashes were significantly reduced. The total CMF 0.93, roadway departure CMF 0.82. For the flattening of the higher slope of 1:3 to 1:4 or 1:5, again, the roadway departures were significantly reduced by 5%. And here is the roadside flattening result for the CMF. If we reduce it from a steeper angle of 1:2 or 1:3 to the 1:4 or 1:5 slope, roadway departure will decrease by 14%. So this is just an example of the study, and the report is in the process of being to be published. Hopefully we will have it in a month or so. Feel free to send me email for the entire study. I'd be happy to answer your question on this, and thank you for the opportunity.